Now let us discuss position of a point with respect to circle. Whether the point is lying outside the circle or on the periphery of the circle or inside the circle. Let x square plus y square plus 2gx plus 2fy plus c equal to 0 be the equation of circle. Its center is c minus g comma minus f and radius r equal to root over g square plus f square minus c. Now see, here we have this circle. Inside this we have marked the center minus g comma minus f. Now if the point P is outside the circle, this point is outside the circle, then the condition will be, see here, this is the distance between point, external point P, that point is external point to with respect to the circle. Now this distance CP will be greater than r. This is radius. Till here we have radius up to this point. Okay. Now if the point is lying outside the circle, then the distance CP will be more than r. So the first condition here is the point P of x1 comma y1 lies outside the circle, then the distance CP will be more than r. Okay. Now similarly, if we have a point P, okay, here second condition, if the point P is on the circle means on the periphery of the circle, then the distance from center is CP, the distance, and here it will be equal to radius. So both are equal, right? So the point P lies on the circle, then the distance between center and point P will be equal to r. Okay. Now if the P point lies inside the circle, let us take the point here P. Okay, let us take the point here. Now the distance between the center and this point will be CP, which is less than radius, because radius will be up to the periphery. So here the distance between this center and P will be less than radius r. Okay, so the point P of x1 comma y1 lies inside the circle if the distance between CP is less than r. Okay. Now x square, let us note this point, x square plus y square plus 2gx plus 2y plus c less than 0. Less than 0 inequality represents the region inside the circle. Okay. So less than 0 represent the region inside the circle. Okay. If we have the circle, this region is specified by this lesser sign. Okay. For whenever we have greater than 0, then this inequality represents the region outside the circle. Okay, the region will be outside the circle if inequality is greater than 0. Now let us denote if point P x1 comma y1 is substituted in equation of circle, then we have this x square plus y square will now become, let me take it as, let the circle will be taken as s of x comma y. Okay, let us denote the equation of circle with s of, because the circle equation is a function of x and y. So I am denoting it with s of x comma y is equals to x square plus y square plus 2gx plus 2fy plus c is equals to 0. Now if I put the point into this equation of circle, this will become x1 comma y1, s of x1 comma y1, which is denoted simply as S11, which is denoted simply as S11 will be x1 square plus y1 square 2gx1 plus 2fy1 plus c. Okay, this will be the S11 value. Okay, S11 means the point is substituted into the equation of a circle. So the condition for knowing whether the point is lies outside or inside or on the circle is S11 will be greater than 0. If we put the point into the equation of circle, if the value is more than 0, then the point will be lies outside the circle. If S11 is equals to 0, the point will lie on the periphery of the circle. Similarly, S11 less than 0 indicates the point lies inside the circle. So from now onwards, we use this condition to confirm the point is outside or inside or on the periphery. So we use these three conditions directly instead of finding Cp greater than R, Cp equal to R, Cp less than R. Okay. Now let us see this question. The circle x square plus y square minus 6x minus 10y plus k does not touch or intersect the coordinate axis and the point 1, 4 is inside the circle. Find the range of values of k. Given equation of circle is x square plus y square minus 6x minus 10y plus k equal to 0. Now center C will be half of the coefficient of x with opposite sign, that will be 3, half of the coefficient of y with opposite sign, so this will be 3, 5. Now radius will be r equal to g square under root g square. G square means minus 3 square, because this center is minus g comma minus f. Okay, so minus 3 square minus 5 square, here we have plus k, so take minus k using the formula of radius root g square plus f square minus k. So the radius will become under root 9 plus 25 minus k, so this will become root 34. Root 34 minus k will be the radius. Okay, now it is given that if the circle does not touch the x-axis, if the circle does not touch x-axis, then radius will be less than y coordinate of center. Let me show this to you. See here, we have a circle like this. This is the coordinate axis. Now here we have the center C 3, 5. Okay, this is the center. This is the radius. This one up to here the radius will be there. But this phi is the length from x-axis up to this point C. So whenever the circle, this is x-axis and y-axis, if the circle is not touching the x-axis, it means that the radius will be less than y coordinate. Radius will be less than y coordinate of the center. So radius here is root over 34 minus k less than y coordinate of center is 5. Now apply squaring on both sides. This will be 34 minus k less than or equal to 25 minus k less than equal to 25 minus 34. So we have minus k less than minus 9. Okay, if I remove this negative sign, this lesser will become greater. So k will be greater than 9. Okay, we got one condition. Okay, we got first condition, k should be greater than 9. Similarly, if the circle, it is given in the question, if the circle does not touch the y-axis or intersect the y-axis, then what happen? The radius will be less than x coordinate. Radius will be less than x coordinate of the center. See here, this one. This is the radius up to this point, but x coordinate will be from here. The x coordinate will be from y-axis up to that point, so it will be less. So radius is root over 34 minus k less than x coordinate is 3. Now squaring on both sides, we have 34 minus k less than 9 minus k less than 9 minus 34. Okay, this will become 25 minus k less than minus 25. Okay, now if I remove the negative sign, I'll get k should be greater than 25. This is the second condition for the value of k. But k greater than 9, k greater than 25 means this condition is more important because it rejects the value of k greater than 9. Okay, now in this question the condition is the circle do not touch or intersect the coordinate axis, and the point 1, 4 is inside the circle. One more point is given. Let that point as p. Let p is equals to 1, 4. Let us take this p 1, 4, and that is inside this circle. Okay, we have that inside the circle. Let me mark it here. The point is p is inside the circle. Now look at this. This point p distance is cp, which is less than r. Okay, here r will be here up to periphery, but cp will be up to this point only. So as the point, let this point is inside the circle, means distance between cp should be less than radius r. Okay, let us find out the cp distance using distance formula, right? Here c value is 3, 5. This is c and this is p. Now the distance will be under root x2 minus x1 square, 3 minus 1 square, 5 minus 4 square should be less than radius. Radius is root over 34 minus k. Okay, here this root and this root will get cancelled. 3 minus 1 is 2, 2 square will be 4, plus 5 minus 4 is 1, 1 square will be 1 only, less than 34 minus k. Now this will become 5 less than 34 minus k. Take this k to this side, k will be less than 34 minus 5. So k will be less than 29. Okay, by combining all this is the third condition for k. Okay, by combining all this, all the conditions, the value of k will be, by joining all this, the common region for the values of k will be k should be less than 29 and more than 25, means less than 25. So the k should lie between 25 to 29. This will be the answer, because if k is greater than 9, k greater than 25 is not possible. Okay, so for greater, take the greatest value. So 25 is greater between 9 and 25. So the answer will be k lies between 25 to 29. These are the range of values. Okay, these are the range of values of k. Now let us see the maximum and minimum distance of a point from the circle. Let the equation of the circle be x square plus y square plus 2gx plus 2fi plus c equal to 0, and its center is c minus g comma minus f, and radius r equal to root over g square plus f square minus c, and we are considering a point p of x1 comma y1 from where we are going to find the distance of the point from the circle. Okay, now let us mark the center of this circle. This will be, center of the circle is c minus g comma minus f. Okay, now let us take a point p. Let us take the point p outside the circle, that is x1 comma y1. Okay, now I want to find out the maximum distance of this point p to the circle. Okay, so if I draw a line from this point, I'll get one line up to here, up to this periphery, and other will be up to this point. Okay, so I want maximum distance. So as I want maximum distance, so I'll take this line, or I'll extend this line through center C up to the other side of the periphery, because I want maximum distance. Okay, this will be the maximum distance. Let us mark this point as A. Okay, let me mark this point as A. So the maximum distance will be P to A, right? The maximum distance will be P to A. PA will be the maximum distance. Okay, now if I want the maximum distance in terms of center and radius, that will be, see here, I can split this distance PA into these two parts. P up to this will be PC, and here it will be the radius. From center to A will be radius. So the PA can be taken as PC, the distance from point P to center, plus the radius. This will be the maximum distance of any point to the circle. Remember this, PC plus R will be the maximum distance of this point from this circle. Now I want minimum distance. So if I want the minimum distance of this point P to this circle, so I'll select this point here, the nearest periphery. Okay, nearest point on the periphery. So let us take this point as B. So I want this length PB will be the minimum distance of this point to the periphery. So minimum distance will be PB. Okay, I want to write this PB in terms of center and R. Okay, so this will become P to C will be the total distance. I want minimum distance in terms of radius. Okay, so till here point B to C will be radius. Okay, so the PB distance will be complete PC P to C distance. So out of this P to C distance, we have to remove PC distance, that is R, minus BC distance. BC distance is R. So PC minus R will be the distance, because we have total distance. I want this distance, okay, PB. So I can get it from total minus this part, okay, will give us this part, okay, this one. This is PC minus R will be the distance between these 2 points, okay. This point can be anywhere on the positive x-axis or negative x-axis. That's why I'm taking mod here. Mod of PC minus R will be the minimum distance. So remember these two as the formula: maximum distance, max distance, this is min distance. Always relate the point with center, okay. Find the greatest and the least distance of this point P 10,7 from the circle. Now compare this equation of circle with standard equation. Let us take this as equation 1. So here we have 2g value as minus 4, 2f value is minus 2, and c value is minus 20. Okay. So the value of g will be minus 2, f value will be minus 1, c value will be minus 20. Okay. The center of the circle, we have minus g comma minus f, that will be 2 comma 1, half of the coefficient of x with opposite sign, half of the coefficient of y with negative sign. Now radius will be r is equals to under root g square plus f square minus c. So this will become root over g value is minus 2 square, f value is minus 1 square, minus of minus 20. So this will become root over 2 square 4 plus 1 plus 20, that is root 25. Root 25 is 5. So the radius is 5. Now we know that greatest distance of point P 10,7 to circle is greatest distance or maximum distance is PC plus R. PC plus R, just now we have seen that here the maximum distance will be PA, P to A, that will be PC plus R. Okay, now I want PC here. PC is the distance, or PC or CP. We have this as x1, y1, and this as point P as x2, y2. Now the distance PC or CP will be under root distance formula x2 minus x1 square plus y2 minus y1 square, 7 minus 1 square, just difference of coordinates, 8 square plus 6 square, this will be 64 plus 6 square will be 36, so root 100, that will be 10. So the maximum or greatest distance will be 10 plus 5, that will be 15 units. This is the maximum distance of this point from the periphery, point on the periphery of the circle. Now the second question is least distance. Least distance of point 10,7 to circle is, formula is PC minus R mod. So 10 minus 5 will be mod 5. Mod 5 value is 5. So 5 units. Find the points on the circle. Okay, we have to find points on the circle which are farthest and nearest to this point. Okay. Now compare this equation with standard form. Here I will get 2g is equals to minus 2, 2f equal to 4, c is equals to minus 20. So the center center C is equals to minus G comma minus F will be 1 comma minus 2, and radius R is equals to root over G square plus F square minus C, minus of minus will be plus 20. So the radius will be 1 plus 4 plus 20, 25. Root 25 value is 5. So radius we have 5. Now let us mark the center here. This is the center C, that is my 1 comma minus 2. Okay. Now we have been given this point minus 5 comma 6. Let this equation of circle, let equation of circle be as S equal to x square plus y square minus 2x plus 4y minus 20. Now let us find S11. S11 is nothing but x1 square y1 square minus 2x1 plus 4y1 minus 20. Okay, here x1 y1 will be here. X1 comma y1 is the point given in the question, that is minus 5 comma 6. I am doing this to confirm this point is lying outside or inside or on the periphery. Okay, now put this value here. S11 is equals to minus 5 square plus 6 square minus 2 into minus 5 plus 4 into 6 minus 20. 5 square will be 25 plus 6 square is 36 plus 2 5s are 10 plus 4 6s are 24 minus 20. Okay, this value is greater than 0. Okay, hence we say that S11 is greater than 0. Obviously this is a positive number, so S11 is greater than 0. Now I can say that the given point P of minus 5 comma 6 lies outside the circle. It is outside the circle. Okay, let me mark it here. Let me mark this point here. P of minus 5 comma 6, this is outside the circle. Now let me draw a line joining the center to this point. Now I want farthest and nearest point. Okay, farthest and nearest point on the circle. He said find the points on the circle. So on the circle we have one point here and one point here. If I extend this line, the other point will be here. This will be the farthest point. Okay, this is far point and this is near point. Okay, we want these 2 points on the circle. Okay, now let me find the slope of this line CP. We know the 2 points. I am finding the slope of CP or PC. Okay, PC will be y2 minus y1. y2 is minus 2 here, y2 minus y1 is 6 by x2 is 1 here minus x1 is minus 5. So this will be minus 8 by 6, 4, 3. So this will be minus 4 by 3. So slope slope of PC is minus 4 by 3. Let us take this slope as tan theta. Okay, slope will be denoted by tan theta. Okay, with respect to horizontal, if it is making an angle theta here, so with the horizontal, so tan theta is the slope of this line PC. Now tan theta is negative. This is negative. Okay, tan theta value is negative. Negative means tan theta will be negative in only two quadrants. In only two quadrants, tan will be negative, either in quadrant 2 or in quadrant 4. Okay, in quadrant 2 or quadrant 4, the tan will be negative. Right, now this tan can be written as sin theta by cos theta. Now take this minus 4 by 3 as 4 by 5 divided by minus 3 by 5. I'm dividing by 5 because if I draw a triangle, right angle triangle for this tan theta, I'll get opposite 4, adjacent 3, the hypotenuse will be 5 by triplet. Okay, by Pythagoras theorem we got. Now sin theta will be opposite by hypotenuse, cos theta will be adjacent by hypotenuse, and I'm taking negative sign to cos theta because in I'm taking the theta in quadrant 2. Okay, this belongs to, this tan theta belongs to quadrant 2. That's why I am taking sine positive. Sine will be positive in second quadrant and cos will be negative. So that implies sine theta will be 4 by 5 and cos theta will be minus 3 by 5. Okay, we got sine theta and cos theta. Now on this line, we know this point C. I want this point, let us take this point as A. Okay, I want this point A here. I want point A, and we know the other point on the same line, and slope is also known. Here we have x1, y1. Let us take this as x1, y1, and we know the slope of this line. Then we use this concept, x1 plus or minus r cos theta, comma y1 plus or minus r sin theta will be the other 2 points on the same line. Okay, on the same line. Now x1 will be 1 plus or minus radius of the circle. Here the distance between C to A and C to B will be r. R value is 5 here, so it will be 5 into cos theta. Cos is minus 3 by 5. y1 will be from center, minus 2 plus or minus 5 into sine is 4 by 5. Now this 5 get cancelled. 1 plus or minus 3 comma minus 2 plus minus 4. Now take one time positive. Let us take it as point A. 1 plus of minus 3 comma minus 2 plus of 4. Take this one point and take other point B as 1 minus of minus 3 minus 2 minus 4. So here I'll get A is equals to 1 minus 3 will be minus 2, 4 minus 2 is 2, and point B will be 1 minus will be 4 minus 6. Okay, we got these 2 points. A will be the nearest, this will be the nearest point, nearest to P, point P, and B is nearest to farthest to P. Farthest to P. Okay, clearly this is nearest, because if I find the distance between this P to A, that will be less than P to B distance. Okay, we got the 2 point on the circle.